Hi everyone, this is Professor Oaks, and in this video we are going to talk about exponential and logarithmic functions with base other than base e. So first, here we have the derivative of exponential functions with bases other than e. Alright, so the first thing that you may want to remember is that if the base were e, then we would have, say, the derivative with respect to x of e to the x is going to just be e to the x. Alright, now if the base is not e, then we have the derivative with respect to x of some other number to the x is equal to a to the x times the natural log of a. But if you look at that here, you could actually do that here and have natural log of e here, but natural log of e is 1, so you have e to the x times 1, so it's still e to the x. Alright, so this is not a new rule here, it's just that before we were looking at a special case of this rule. So let's differentiate each function here. So y is equal to 2 to the x. So y prime, or dy dx in this case, will be 2 to the x times natural log of 2. There you go. What a time to be alive. Let's try another one here. So we have y is equal to 2 to the 3x. So dy dx, or y prime, is 2 to the 3x, all right, then times, now we need the natural log of 2, but then we need to also multiply by the derivative of this exponent here, which is going to be 3, all right, so times 3. Now, you notice how I put the dot for multiplication here because I didn't actually want to accidentally multiply this 2 times the 3 because this 2 is part of the argument of the natural log here. All right, so it might be safer to write it as 3 times 2 to the 3x natural log of 2 just so that you don't accidentally multiply 2 times 3. All right, so let's try another one. We have f of x is equal to 6 to the negative 5x, so dy dx, or in this case f prime of x, will be 6 to the negative 5x times natural log of 6, and then times the derivative of the exponent here. So again, we need to make sure to use the chain rule. So this will be times a negative 5, and again it might be better to write it as negative 5 times 6 to the negative 5x natural log of 6. Alright, so the next one is y is equal to x times 6 to the negative 2x. So here we see that we should use the product rule. So so we have x times the 6 to the negative 2x, so use the product rule for derivatives to find this derivative of y here. So u will be x and v will be 6 to the negative 2x. So u prime is 1, v prime is, actually, what is it? It's 6 to the negative 2x times natural log of 6 times the derivative of the exponent, so negative 2, or negative 2 times 6 to the negative 2x natural log of 6. So then y prime in this case will be, all right, so 1 times 6 to the negative 2x, so u prime v plus uv prime, which will give us 6 to the negative 2x, and then minus the 2, so I'm just going to write it like, instead of, well, I guess I could write x times negative 2 times 6 to the negative 2x natural log of 6 like this, but it might be better just to write it as, all right, 6 to the negative 2x and then minus 2x 6 to the, well, I really don't know how you want to write this. I don't know if you want to write the x at the beginning, or how you would like to write that, but you just want to make sure, again, even if you move the x to the end, then you don't actually think that's 6x by accident. All right, so this will be my final result here. You can factor out a 6 to the negative 2x if you want, but in either case that will be my final result, except for any simplification that I may want to do. All right, so let's try another one here. So this next short little topic here will be the derivative of logarithmic functions with bases other than e. So again, let's think about what would happen if the base were e. So derivative with respect to x of the natural log of x is just 1 over x. And then here you have derivative with respect to x of log base a of x is equal to 1 over x ln of a. So then, well, the natural log of x, the natural log here has a base that is e. So this will be natural log of e here. And then, well, natural log of e is 1, so this is still 1 over x. So again, this is not a new rule, it's just that this rule that we had before was a special case of this rule here. So let's differentiate each function here. So we have y is equal to log base 5 of cosine of x. So what do you have? Well, you have 1 over the cosine of x, so 1 over whatever this is that we are taking the log of, all right? And then the natural log of the base, so the base with 5, so times the natural log of 5 in the denominator here. And then if you think about it, then you need to use a chain rule and multiply by the derivative of the cosine of x, and that will be, well, that will be a negative sine of x. All right, and the negative sine of x over cosine of x, that is negative tangent of x, so that will be negative tangent of x over the natural log of 5. So that is the derivative in this case. So y prime, that's what y prime is equal to, the derivative. All right, let's take a look at this next problem here. So we have h of x is equal to log base 3 of x times the square root of x minus 1 over 2. So there are a couple of ways, of course, I could approach this, and one of them is by using log rules first to make this log base 3 of x plus log base 3 of the square root of x minus 1 plus log base 3 of, well, you could actually just make this a minus. That might actually make it easier in the long run. So then minus the log base 3 of 2, and then the square root of x minus 1 is actually x minus 1 to the 1/2 power. So then I can use log rules to bring the power in front of the log here. So log base 3 of x plus 1/2 log base 3 of x minus 1 minus log base 3 of 2. So now, what do you do after this? Well, you find the derivative. So h prime of x, the derivative of log base 3 of x is 1 over x natural log of 3, then plus 1/2 times 1 over the x minus 1 times the natural log of 3 times the derivative of x minus 1, which is 1, and then minus 0 because the derivative of log base 3 of 2 is 0 since that's a constant. So this is just 1 over x natural log of 3 plus 1 over 2 times x minus 1 natural log of 3. And again, it doesn't matter how you write this final term here, you just want to make sure that you don't multiply that 3 times the 2 or 3 times the x minus 1 by accident. So if you did not use log rules first, what would you end up having here? Well, all right, so you have the h of x is log base 3 of x square root of x minus 1 over 2. So you could just go right for the derivative. So it would be 1 over the x square root of x minus 1 over 2 natural log of 3. But then you would need to use the product or the quotient rule to find the derivative of the x times the square root of x minus 1 over 2. So let's say you let u be x over 2 and v be the square root of x minus 1, or x minus 1 to the 1/2 power, then the u prime is 1/2, and the v prime is 1/2 x minus 1 to the negative 1/2 power, or 1 over 2 square root of x minus 1. So then this will be times the product rule here, u prime v plus u v prime. All right, so that will be 1/2 square root of x minus 1 plus the x over 2 times the 1 over 2 square root of x minus 1. And then let's go ahead and simplify this here. So for the first factor here, I'm going to multiply by the reciprocal. So I will have, well, that will be, if I multiply by the reciprocal, 2 over x square root of x minus 1 natural log of 3. And then we have square root of x minus 1 over 2 plus x over, well, 2 times 2, 4. So 4 square root of x minus 1. Then let's distribute right here. So I have 2 square root of x minus 1 over 2x square root of x minus 1 natural log of 3 plus 2x over, well, this is going to be the 4 times x of 4x, then the natural log of 3, and then square root of x minus 1 times square root of x minus 1 is just x minus 1. And then let's go ahead and simplify here. So the 2's divide out, and then the square root of x minus 1's divide out. So I just have the 1 over x natural log of 3, and then here the x's divide out, and then the 2 over 4 is a half, so it's 1 over 2 times, I'll move this x minus 1 over here, so x minus 1 natural log of 3, just so that it looks like the same result that I had before. And so as you can see, it actually is the same result that I had before, so it doesn't matter which way that you go about finding the derivative of h of x in this case. All right, so now let's go ahead and look at our last topic here. So let me figure out where my page actually went here. So I don't want anyone to be upset here about this delay right here. So now here is the last topic in this section here on logarithmic differentiation then. So find the derivative using logarithmic differentiation. So let me just revisit this last example for a moment here. So try to remember that in this case we could have used log rules to simplify an expression, and look at how much easier it was to find the derivative actually when we used the log rules versus when we did not. So the whole point of logarithmic differentiation is for us to try to figure out how can we involve logarithms in the problem so that we can make the derivative easier to find, all right? Or in some cases, this might be the only way that we can find the derivative of a function very easily, at least. All right, so here's the first one. Y is equal to x minus 2 squared over the square root of x squared plus 1, and x is not equal to 2. All right, so logarithmic differentiation. So we're going to take the log on each side. So log of y is equal to log of x minus 2 squared over the square root of x squared plus 1. All right, so, well, why are we doing this? Because now I can actually use log rules here. So log of y is log of x minus 2 squared minus log of square root of x squared plus 1. And then I will rewrite the square root as the 1/2 power here, so I have x squared plus 1 to the 1/2 power. Then I'll bring the exponents in front using the log rule. So log of y is 2 log of x minus 2 minus 1/2 log of x squared plus 1. And then I will find the derivative with respect to x. All right, so dx. So what do we have here? Well, we have 1 over y and then y prime. So remember, we need to use implicit differentiation here. and then we have 2 times, all right, so that will be 1 over x minus 2 times the derivative of x minus 2, which is 1, then minus a half times 1 over x squared plus 1, and then times the derivative of x squared plus 1, which is 2x. And then if you want to solve for the y prime, you can, but let's go ahead and simplify a little bit here. So 2 divided by 2 is 1. So you have 1 over y prime is 2 over x minus 2, and then that will be minus x over x squared plus 1. And then you just multiply by y on each side. So y and then times y. So the y's divide out. So y prime is equal to y, and remember that y was actually equal to x minus 2 squared over the square root of x squared plus 1. So we have y is equal to the x minus 2 squared over the square root of x squared plus 1, then times 2 over x minus 2 minus x over x squared plus 1. And that is the derivative in this case. What a time to be alive. I really hope that you enjoyed that here. So now we have just one more problem here to do, and just try to remember that for us, that one of the main cases where you would want to find the derivative using logarithmic differentiation is if there is a function where there's an x in the exponent, like here, sine of x to the cosine of x. So let's go ahead and use logarithmic differentiation. So we'll take the log on each side. So log of y is log of the sine of x to the cosine of x. And again, the reason why you want to do that is because you can use log rules to bring this down in front. So log of y is cosine of x times the log of sine of x. Now, what do you do after this? Well, all right, we find the derivative with respect to the x, so d dx on each side here. So the derivative of log of y is 1 over y prime. And then for the derivative of cosine of x times log of sine of x, we need to use the product rule. So let's use the product rule. So the u is cosine of x, and the v is log of sine of x. So u prime is, well, that's negative sine of x, and v prime, well, that's 1 over sine of x, and then times cosine of x. So you could write that actually as the cotangent of x if you would like. So now, what do we have here? Well, we have that well, the product rule is u prime v plus u v prime, right? So we have negative sine of x log of sine of x. Then we have plus the cosine of x cotangent of x. And then all we have to do now is multiply by y on each side. So times y and times y. So now we have y prime is equal to, well, y is sine of x to the cosine of x. So sine of x to the cosine of x power times negative sine of x log of sine of x. And then plus the cosine of x times cotangent of x. So there is the derivative here today. So unfortunately, that is all I have for, well, is there more? Yeah, so that's all I have for that page right here. So let's do a couple more here. So we have C is, well, okay, so y is equal to x squared times sine of x cubed. So the x cubed is like this. I apologize about those missing parentheses. And then times the cosine of 3x plus 7. All right, so what are we going to do about this here? Well, remember that back when we started finding derivatives, then finding the derivative of d dx with respect to a u v w, a triple product here would be u prime v w plus u v prime w plus u v w prime, right? But we don't have to do that in this case. We can use logarithmic differentiation. So we'll take the log on each side. So log of y is log of x squared times sine of x cubed, and then times cosine of 3x plus 7. So now we go ahead and use log rules. So log of y is log of x squared plus log of sine of x cubed, and then plus log of the cosine of 3x plus 7. All right, so notice I'm making sure to be fairly careful about the parentheses because I can bring this 2 in front of the log using the log rules, all right, but I cannot actually do anything with this 3 here. Well, actually, you know what? Okay, forgive me for saying that so quickly, but here's what you actually could do if you really wanted to do something. All right, so yeah, you could actually, if you really insist it, you could actually write sine of x to the third and write that sine of x times x times x and do some sort of crazy identity. But I would actually dare you to do that because I don't think it would end up very well for you. Okay, so I'm just going to rewrite this as log of sine of x cubed, and then the same thing with this cosine of 3x plus 7. You can't really do anything with this here, so I'm just going to write it as cosine of 3x plus 7. All right, so now we'll find the derivative with respect to x on each side. So the derivative with respect to x of log of y is 1 over y prime. Then the derivative with respect to x of 2 log x is 2 times 1 over x. Then the derivative with respect to x of log of sine of x cubed will be, well, that will be 1 over sine of x cubed, and then the derivative of sine of x cubed, so that will be cosine of x cubed, and then the derivative of x cubed, which is 3x squared. Then we have plus 1 over, this will be for the derivative with respect to x of log of cosine 3x plus 7, so that will be negative sine of 3x plus 7, and then times the derivative of cosine of 3x plus 7, so that will be actually I multiplied by the reciprocal by accident, so I was trying to fit it all in one line and it did not work out in my favor. See, that's why I'm telling you. So cosine of 3x plus 7, and then times the negative sign of 3x plus 7, and then times the derivative of 3x plus 7, so times another 3 right here. So now yeah, so you see that this is a big mess right here. So let me go ahead and simplify this for us here. So 1 over y prime equals 2 times 1 over x, so 2 over x. Then I'm just going to write this part here as 3x squared cosine of x cubed all over sine of x cubed. And then we have minus sine of, well, 3 sine of 3x plus 7 over cosine of 3x plus 7. And then if I want to simplify this here, then I could make this into the, well, all right, so we have 3x squared, and then cosine of x cubed over sine of x cubed is cotangent of x cubed, and then minus 3 times sine of 3x plus 7 over cosine of 3x plus 7 will be tangent of 3x plus 7. And then I will multiply all of this by y on each side, so times y. So y prime will be y, which is this right here. So x squared sine of x cubed cosine of 3x plus 7, and then times the 2 over x plus 3x squared cotangent of x cubed, and then minus the 3 tangent of 3x plus 7. And there is the derivative of this. What a time to be alive. All right, so now let's move on to the next one. All right, so here we have f of x is equal to sine of x squared to the 3x. So just try to remember that, as I have said before, part of the reason you want to use logarithmic differentiation is to get the x out of the exponent. So I am going to just rewrite this as just, well, all right, so you can just write y if that would make this a lot easier for you. It might not make it easier for you, but it might. All right, then take log on each side. So log y is log of the sine of x squared to the 3x power, and then use log rules to bring the 3x in front. So log of y is actually 3x log of sine of x squared. Now, I will go ahead and I will use the, find the derivative, d dx, all right, so the derivative with respect to x of log of y is 1 over y prime, and then here I need to use the product rule, so u is 3x and v is log of sine of x squared, and so u prime is 3, and v prime will be 1 over the sine of x squared, and then times the derivative of sine of x squared, so that will be cosine of x squared, and then times the 2x for the derivative of the x squared there. So what do we have here? We have, well, all right, the product rule gives us u prime v plus u v prime, right? So we have 3 log of sine of x squared, then plus, okay, so 3x then times 2x cosine of x squared all over sine of x squared. So then if I want to simplify this a little bit, I could make this into, let's see, what could this be? That will be 3x times 2x, so that's 6x squared, and then cosine of x squared over sine of x squared, that's cotangent of x squared, and then I multiply by a y on each side, so y, so we're left with the y prime, or f prime of x, will be, all right, this was the y was, or f prime of x will then be f of x, so that will be sine of x squared to the 3x power times all of this here, so 3 log of sine of x squared, then plus the 6x squared cotangent of x squared. All right, so there you go. What a time to be alive. I really hope that you enjoyed this example here and this section on the exponential and logarithmic functions with bases other than e, and also our brief discussion of logarithmic differentiation. And I am sad to say this is all that I have in terms of videos on this topic for a while, so I hope that you enjoyed all of them. Thank you and have a great day.